So
Good luck.
thank you. It's to be honest, my very first session in a public community. So cross your fingers, everything will go okay. Okay, so this evening I'm going to talk to you all how you can leverage the container technology to develop scripts using Visual Studio Code. Because it has some advantages and it solves quite some things if you do it that way, but I will get into that. But first of all, a little introduction on myself. So I'm Dries Verschaeve. I live in Gilleveld, which is a small town in the west of Flanders. I'm currently a consultant at the collective since 4 months. So I recently switched towards the collective, and there my role is mainly Microsoft 365 because I started my cloud journey on that platform, and in the recent years I started to shift towards Azure. If you want to find me on the internet, there you have some links towards my GitHub repo, my LinkedIn profile, my Twitter, and then my website, which is basically a resume site and an early attempt on blog postings. So if you want, you can check all those things out. So let me then first tackle why there are some script development challenges. So if you're writing a lot of automation scripts, especially on the Microsoft platform in Azure and Microsoft 365, you write usually PowerShell scripts to manage the environment. And this gives some challenges, especially if you're like me, switching between multiple customers, multiple projects. Each has its own environment where scripts needs to run. They use sometimes a specific version of a PowerShell module, and you need to switch all the time between the environments. Then you switch from project A to project B, for example. Your modules are not okay, or they're conflicting with modules you installed recently, etc. You're missing some software dependencies. So you need to update your machine again, making sure everything is aligned again with the target environment you're trying to develop to. And yeah, especially if you're in a team, my machine may have these kind of modules, these kinds of software. Scripts work fine on my machine. I go on holiday. A colleague needs to take over, needs to fix a bug or something in the script, and he needs a half a day to set up his machine to get the script working on his machine. So this gives quite a lot of issues that actually developing in a Docker container can solve for you. And hopefully by the end of the session, you will see why this is going to solve all of these issues. And let's hope you're shifting as well into this model, or you at least try it out and play around with it. So first of all, let me give you a short introduction on containers and what actually is the major difference between virtual machines running on a hypervisor and containers. So in a virtual machine virtualization, you're actually virtualizing the hardware. So there you have VMs running on emulated hardware. You have your guest operating system, and then you have your application A running on top of the operating system. So the application and the operating systems go hand in hand, and they usually make one big chunk of or a whole on your machine. If you look at a container, on the other hand, it's not the hardware you're virtualizing. You're actually virtualizing the operating system. And each container is just a delta of your original host operating system. So if you're running, for example, Ubuntu that comes with a kernel, and you install, for example, PowerShell inside your container, then actually your container will make use of everything on the host operating system and only host the deltas inside your container. So it's actually a little bit more tailored towards the operating systems. Okay, so how do we make use of this technology to develop inside containers? So Microsoft released actually the development containers. So which is actually a container that's running some software in it. So it's mainly a Visual Studio Code server that's running in there, that's making use of a file system and is running the actual applications. Then you have your Visual Studio Code itself, which is running on the host operating system. And your Visual Studio Code client will actually make a connection towards your Visual Code server, and you're actually getting a seamless experience when you do so. If you worry about, but what about if I change a file inside my container? What happens? Well, actually, the container technology will actually mount your the location of your source code inside the container. So if you make a change towards a file in your source code, you're actually making the change against the file on your file system. To get an optimized experience, there are a couple of components and baselines here that we need to be aware of. So the development of containers actually makes use of the Windows subsystem for Linux. So you need to have this enabled to make use of this technology. You have the VS Code server itself, which will host a Visual Studio server instance that is running your extensions, that is maintaining your code, etc. Then you have the Docker engine itself, which is built, which is running on top of your Windows subsystem for Linux. So actually, the WSL is shortened for Windows subsystem for Linux, is actually managing your computer resources. And Docker is actually using that engine to actually make optimal use of your computer hardware. Then for the Docker instance itself, there are a couple of key files in here. So first of all is a devcontainer.json file. And this is actually instructions for your Visual Studio Code client, how to connect towards your container. The Docker file itself is actually a script that contains build instructions. So how to build your container to make sure you can develop your scripts like you want. And then you have also a notion of container volumes. And this is then, I told you about that you can mount the file system of your host operating system inside your container, or at least the directory with your source code. If you do not want that, you can also have a container volume, which is an isolated storage inside your container, and that's then mainly used if you clone a repository from a public Git repository, and you do not want that the files in there can make a connection to your local operating system, etc. So that's mainly the thing behind that containerized volume. Okay. So how do we get started? First of all, we need to prepare the host for it. So I will give you a demo shortly after this. I already did this on my machine to save some time, but yeah, you need a Windows 10 version, 1903 or higher, to make use of this. You need to have CPU virtualization enabled inside your BIOS. Additionally, you need to run the Windows subsystem for Linux. So I added the commands in there how you can install it on your machines. Important here is that you enable version 2 of the WSL engine, because that comes with a lot of performance improvements for your Docker engine. Then you need to deploy a Linux distribution from the Windows Store. Ubuntu 2004, for example. You also have Kali Linux, Debian, you have and others that you can install. So use the one you like. It's not actually being used as an image for your development containers, but it's a requirement that it's fully deployed. Then you need the Docker engine itself, so Docker Desktop 2.3 or higher with the WSL2 support enabled. And then last but not least, you need to have the remote development extension pack installed inside your Visual Studio Code client. So I added the download link for that one. Once you have installed all of these, you can start playing with this. So now how can we make use of this technology? Well, Microsoft has prepared, or the community around it at least has prepared pre-configured containers for all sorts of development projects. So, and the list is quite extensive. So here I give you some examples on what is possible, what containers are available, and the link is down below to even have more containers available. So if you're having, for example, a Azure Bicep project coming up and you need to start developing the infrastructure as code definitions for your project, you can choose to use the Azure Bicep container. And it will, once you kick it off, it will actually contain all of the software dependencies for Azure Bicep, extensions you can use for the IntelliSense, etc. So as soon as you start up that container, you will be able to go with your Azure Bicep development. Same for Azure CLI. If you need to create a script that's based on Azure CLI commands in Bash, use that container and you will be ready to go. Same for Azure Functions. There you need to install all kinds of software, the FUNC executables, etc. If you select that template, your environment will be totally pre-configured. Another one is Azure Terraform. So if you're having a Terraform project, Python 3 is in there. I would say take a look at the link below, and you will see what public images are already available. Okay, so I'm going to now go a little bit more demoing, and I'm going to show you how you can actually start such a container. So let's switch to our Visual Studio Code client. And first thing, so if you're in the main window and you have the remote extension installed, you can go to the command palette via the view, command palette. And if you now search for remote containers, you have the possibility to open a folder in a container. If you select that one, you need to select which folder you wish to open, and it will be this folder that Visual Studio Code will mount inside the container. So I'm going to create a new one. Let's say Azure CLI. Let's open up that one. Open the folder. And now it's going to give me a list of possible images that I can use. The initial list is not that extensive, so it's a couple of common images they provide to you. However, there's a show all definitions button, and then the list gets a little bit more expanded. So as you can see, quite some possibilities you have in there just to start your scripts. So here I'm going to select Azure CLI. There are some images that allow for customization. I'm not going to do this right now, so we're just going to select the default option. And now it will actually start building that container. So this will take a while. Usually this one is pretty quick, and you can actually monitor the progress a little bit in the background. So here you can witness how the actual container is being built. If you do not have the operating system image yet for the container, Docker will make sure it downloads it from the public repository. In the meantime, I'm going to show you what's being created inside the folders. So by selecting that option, open in remote container, it will actually create a folder inside the selected location called the dev container. And inside that folder, you will see some files. So the dev container.json file I already mentioned. And if you take a look at that, there it is. This is actually a JSON file containing some settings. Visual Studio Code knows what to do with this, and it's actually the connection towards your Docker container. And then you have the Docker file itself, which is actually a fully fledged deployment script. What they're doing to deploy this container. So there are some commands that are being executed upon build, and some scripts that are being executed. So how do you know when it's ready? Well, if you look here on the left-hand side, if you see the container name, that means it's connected. If you do not see this, it's still building. And now if I open up a terminal inside the container, you will see that I'm having AZ login. Let's use it without the. So when you open up AZ login, it normally prompts you. It opens you an Edge or your default browser, and it goes to to ask you to authenticate. So this to show you how good the integration between the container and the host operating system is. So it's able to launch a browser on your host operating system, prompt you for login. I'm not going to log in right now, but if I would do, then my container is actually logged in inside Azure, and I will be able to execute Azure CLI commands. Okay, so this is the list of the public available images, and if you start doing this, I would propose to use these and have a look on how they're actually being, or how the containers are actually being built. So all the information is in there, it's publicly available, so it's quite interesting. But I still have another exercise. So yeah, if you would look now, I'm going to cancel this out. So if you would look for the version of the operating system, this is actually the Buster image, so a Debian build that's being executed. So check release, and let's be -A. So this is a Debian build. Say that you standardized in your company on Ubuntu, etc. Then you obviously want to have a development container tailored towards your environment itself. So I'm going to walk you through it and build one from scratch here. So a very simple container custom image we're going to use based on Ubuntu. So that hopefully you see the concepts behind it and see and kickstart you to make your own development containers actually. So let's get to it. And let's start with an empty folder. So I'm first going to open up a folder. Custom image. So now I'm actually stepping out of that Azure CLI container and switching back to the full Visual Studio Code client running on my host machine. And the first thing I need to do is actually creating that dev container folder. And here I will create my dev container.json file, which will my connection parameters towards my new container I'm creating. So I'm going to give that a name. MC seems appropriate here. And then to start with, I'm going to give an image file. Because it's Microsoft.com. Base.vocal. So that's actually the Ubuntu 2004 image that I'm instructing to use. So if I'm now going to build this one, I'm pressing F1 to open up my command palette, and now I open it up in a container. So I'm selecting my custom image. You're seeing it's building if you see opening remote here. And then you can follow its progress here as well. And this one will go pretty quick, actually. And obviously you have an error. So if this happens, it will automatically switch again back to your local copy. And I must have made an error here, or give me a second. So let us see if the build log says something. Container was started. Okay, must be an error in my URL here. Let me just copy it. From there. What's wrong here? mcr.micros/VS Code. Dev containers. There we are. Happens when you there, and let's reopen it now. Okay, my container is started now. Okay, there we are. So container is started, and if I open up a terminal, you will see if I execute again lsv release -a, it's Ubuntu. However, I already see something that I do not find best practice. So yeah, if you do who am I, you will see that I'm currently running as root. So in a Linux environment, you do not want that you have direct root access. So let's fix that, because each of those images that are published for development containers, they usually contain already a username out of the box, which is not as that does not have root privileges. So we need to specify this, which user it needs to use, and that will be VS Code. Another thing that I want to do is if you look here at this image, it does not include PowerShell. So that's not the goal of this custom image. I want to have a fully fledged PowerShell environment. So we did not instruct the build process to install PowerShell. So we need to adapt our dev container settings a little bit. So first thing we need to do is actually create a Docker file which will contain the build instructions. And here I need to shift this one to my Docker file. So I'm saying use this image. And then I need to have a script that actually will deploy PowerShell. So we do not have PowerShell yet, so that needs to be a bash script. It's Ubuntu. So I will need to have that, or at least add that script inside my container. So I'm going to create a folder for this, deploy, and inside it I will create a script, PowerShell.sh. And for this one, I'm going to copy the code already pre-filled in. So these are the installation steps, official installation steps to deploy PowerShell core on Ubuntu 20.04. And it will also enable PowerShell as the default shell for my VS Code user. So I have my deployment script, but it's not yet in my container. I first need to copy it inside my container so that it's available inside the container when it starts, so that it can be deployed. And I'm going to copy it into a temporary folder called tmp deploy. Next thing I need to do is actually launch the script when the container starts, or is being built at least. So let's go a run. First, I'm going to update my repositories. And then I'm going to launch the script. Deploy PowerShell.h. Okay. So I think we have everything. We have our command being executed. We have our PowerShell.sh script, and we have our directive that executes our script. Okay, so let's rebuild our container. That's also an action inside your command palette. So if you make a modification, then you can just hit the rebuild, and then it will rebuild the entire thing again from scratch. So let's monitor the progress a little bit here. So while it's being run, so I hope you can now see the main advantage to get things solved here for our development area. So actually, your development container travels along with your source code. So if you check it inside a GitHub, for example, then your definition of your development environment travels along with it. So if your colleague needs to take over, just clones the repository, he builds the container himself, and he just can start working. Because, yeah, you tested it, it was working. So the idea behind the container is if you take it from machine A to machine B, it should just work. So this is already a huge advantage. One of the disadvantages, I must say, especially if you're developing against Microsoft 365s, not all PowerShell modules do already support PowerShell core. So it's only specifically for those modules who already support PowerShell core. So for those, it's still waiting for Microsoft to update their modules to support PowerShell core everywhere. Okay, in the meantime, it's done. So, and now if all goes well, and it doesn't, I don't have any PowerShell available. No, I do not want that. I want my build log file. Okay. Okay. That's a pity. What did we do wrong? Going to rebuild it. Give it one more try. It did not give any build errors, so okay. It's a no-go. Something went wrong here. Just see if I forgot something. No, not really. Okay, let's move on then. Sorry, I wished I could have completed it entirely. However, the source code for this is, or at least the build I was building is located. Here, I know what's wrong. Sorry. Now I see it. Here we need to change this to Docker file. And I'm going to give it one more build. And in the meantime, continue my presentation. Sorry, Docker file. Yeah, I needed to specify, needed to use the Docker file, obviously. Rebuild container, there we go. So to speed up a little bit, so on my GitHub repository, you will find the full code for that build. So what it's actually doing is it will deploy a couple of things. So if you look at the full Docker file itself, besides PowerShell, it will also deploy Git. Next to that, it will also deploy my PowerShell modules I want to have. So, and for that one, it actually downloads a desired state configuration script I wrote, where you can specify with a JSON file which modules you want to have deployed. So in my demo, I would have continued deploying AZ accounts, but I will not be able to finish that in 10 minutes. So it will deploy AZ accounts and the Exchange Online management modules inside the Docker image. So, and it's doing that based on a JSON file. Additionally, if you look at the dev container itself, so remember that extensions also run in that Visual Studio Code server. So that also means that your PowerShell extension, for example, as soon as you connect to the container and it's not installed on the Visual Studio Code server, you won't have your IntelliSense, your code completion, etc. for PowerShell. So you must specify inside the dev container file that you want to have that file or that extension at least deployed inside your container itself. So you can do that by specifying which extensions you want, so that they are available as soon as your environment spins up. And now I'm having a build error. Okay, forget about this. What else is there, or at least important to know? I think I covered it all on this one. Okay, so then let's wrap up. So there are a couple of things that you need to know of. So first of all, because the Docker engine is using the Windows subsystem for Linux to manage your hardware resources, you need to do you can do some advanced configuration on VSL itself. So there you can, for example, say that VSL does not need to configure naming resolution files in Linux, etc. So there you can, if you do not want that, you can configure it there. And you can also limit which resources the host allocates towards your Docker container. So like CPU usage, memory, and local host forwarding. So I added pointers to the relevant information that can help you configure these things if you need those. And then last but not least, if you're using GIT SSH keys, so if you're pushing code to a Git repository, you can use SSH keys to do that. But because your SSH keys exists on your host operating system, which is in this case is Windows, you need to expose, or at least share your SSH keys with your container instances. And for that, you need to have an agent running, so the SSH agent, which is available as a Windows service. So you need to enable this service, make sure it's running, and then add your private key, which you use to authenticate against GitHub, for example, towards the SSH agent, and that will allow you to do Git pushes towards the Git repository using SSH keys. And by that, I'm through my presentation. So I hope you found it useful, and yeah, it's a pity that the demo, at least the advanced demo, failed a little bit. But okay, that's how sessions go, I suppose. Thank you.
That happens to all of us, Dries, so don't worry about it. Nice session, thank you. Does anybody has a question for Dries? So you can unmute. I didn't say anything in the chat.